I'm just kind of reviewing what we went through last week since we had a lot of absences and stuff, and understandable that you guys might want to just review what we've done. This is basically bringing in the whole stuff that we've learned up to date, where we've graphed lines. So right now we're dealing with systems of equations, are two equations with the same variables. All right. Graphically, the solution to a system of equations is where the two lines intersect. Okay. So when we're finding the point where those two lines intersect, it's actually, if it makes both the equations true or equal. All right. So there's three types of solutions when you solve a system of equations. You can have intersecting lines where they intersect at one point. All right. And if you, when we're doing this by graphing, we're putting everything into slope-intercept form. So for this, I always tell everyone, you know that they're going to intersect if their slopes, which is the m, are different. Okay. Now, parallel lines are lines that never intersect, okay? And if you remember from our past unit, if we have two lines that are parallel, the slopes are the same. So the slopes are the same. But the y-intercepts are different, okay? And then when they're the same line, there's infinitely many solutions, okay? Because it's the same line graphed right over itself. So the slopes are the same and the y-intercepts are the same. Okay? So when we're solving by graphing, what we have to do is make sure everything's in slope-intercept form, which is y equals mx plus b. Then we graph each line. Now, as a reminder, remember b is your y-intercept, and that's what we call your starting point. All right. Your slope is like your GPS. It's telling you where to go. So you're going to use rise over run. Okay. And you're going to have to most likely go into two different directions when you're doing rise over run. So remember, most of the time we go up or down and to the right. And then, but now we're going to also have to go to the left, which means we're going to do the opposite direction that we would do to the right. And I'm going to show you what that means. Okay. So let's start with a couple of examples. These are already in slope-intercept form, and which is good, but we're going to go over a few that aren't. So you have to remember how to put things in slope-intercept form. So when you have y is equal to x minus 8, you have to graph each line separately. So y is equal to x minus 8. Now remember, that number in front of x, even though we don't see it, is positive 1. All right, so my starting point is the point 8, which is your y-intercept, I'm sorry, negative 8. So it's 0, negative 8, which is your y-intercept. So that's going to be here. I always start at the origin when I graph a line, and I'm going to go down 8 spaces. So it's going to be right here. Okay, and then my slope is my rise over run, and it's 1 over 1. So remember that if you have a whole number as a slope, the number on the bottom is always 1. So this tells me from that point, I'm going to go up 1 and over 1 for each one. So the way I would do that is up 1 over 1, and I continue the process. And it's important to continue this process because you're going to find a point where they intersect. Now, what's nice about these graphs is that they're going to intersect on the lines that we have here, on the graphs that we have here, which is nice. They're not going to be off the graph. but you know, definitely keep that in mind. Now, if you notice, I went to the left of this point. So instead of going up 1 and to the right, I went down 1 and to the left. And I connect these all with one line right here, okay? All right, so now I have to do the next point, the next problem. That's y is equal to negative 2x plus 1. So y is equal to negative 2x plus 1. So again, my y-intercept is at 0, 1. So it's right here, okay? And when I do my slope, it is negative 2 over 1. So I would go down 2 over 1. So from there, I go down 1, 2 over 1. And I keep repeating the process until I intersect my line. So I go down 2 over 1, and look right there, I intersect right here at this point. So I'm going to continue it on for a couple more points, and then I can just connect them with a line. And then my solution is this point right here where these two lines intersect. So just getting this point, remember I always start from the origin. So to get to that, I go over 3. So since I went over 3, it's positive 3. I went to the right. So when you're writing your x and y values, remember, if you go to the right, it's positive. To the left, it's negative. And if you go up, it's positive, and down it's negative. So I went down here. So that is 1, 2, 3, 4, 5, right? So this point is 3, negative 5. So because I would go from the origin, I would go over 3 and down 5. 1, 2, 3, 4, 5. Okay, just as a review. Now this one is pretty much the same thing. We'll do one more of those and then we'll start doing some other ones. So here again, my slope and my y-intercept. I'm going to use this one right here. Sorry. I have y equals 1/2 x plus 9. So my y-intercept is at the point 0, 9, which is right here, okay? So that's going to tell me I'm going to need to graph this line this way and this way, all right? So my slope is 1/2. So normally I would go up 1 and over 2, okay? So I went up 1 over 2. Okay, I can't go up 1 and over 2 anymore, else I go off my graph. So what I'm going to do is go down 1 and over 2 to the left. So instead of going up, I go down, and then down 1 to the left 2, and then I continue that until I run off the graph, okay? I do that because I want to make sure that that graph is easily read and that I make sure I have the possible intersection point in there. Okay, the next one is y is equal to negative 1 times x plus 6. So my y-intercept is at 0, 6. That's my starting point. 1, 2, 3, 4, 5, 6, right? And my slope is negative 1 over 1. So normally I would go down 1 and over 1, right? So let me show you that. Down 1 over 1, down 1 over 1. Okay, what do you notice about this line? It's going away from this line, and I need to find an intersection point. So I can continue this, which is fine, but I still have to find an intersection point. So in order to do that, I'm going to go up 1 and to the left 1 and continue that until I do find an intersection point, which is right here. So then my line, and if you notice, you're doing it right. If you graph it and it still stays straight, remember a line has to stay straight. It has one slope and that's the only way it goes, all right? So to get to this point, I go over 2 to the left. So that's negative 2, and then I go up 1, 2, 3, 4, 5, 6, 7, 8. So negative 2, 8 is my solution. Okay, so let's look at a couple more examples and then I'll wrap it up. So this is just giving you a summary of what we did in class. So hopefully you guys are in pretty good shape for that. So I'm going to go to this one right here, number 4. This is all in class practice, guys. Now, if you notice, this one is not in slope-intercept form. So I have to do some work to get it into slope-intercept form. So I'm going to use some extra paper. Now, you can always do this on another sheet of paper. So you kind of have to write small if you're doing that. So let's go ahead. All right. And I'm going to look at this one right here. So I have 1x plus 2y is equal to 4. All right. So that is, sorry guys, just trying to, okay. So 1x plus 2y is equal to 4. So what I'm going to do is I'm going to subtract. Remember, to solve for y, you want to get it in y equals mx plus b. So y needs to be all by itself. X needs to be over here and the constant needs to be over there. Now, as a reminder, guys, when you're putting this in slope-intercept form, I'm going to bring this x term over to the other side. You cannot add these two numbers at all, okay? So you have 2y is equal to negative 1x plus 4. Now what do I do? Now I need to solve for this y. So if I covered my finger up on this and said, okay, how do I solve for y here? I would say I divide by 2. So I'm going to do exactly that. So you are doing some more work here than you normally would in other situations. So this ends up being y is equal to negative 1 half x plus 2. Now that is this equation. But if you notice, these two are exactly the same. All right? These are exact same questions, so equations. So when the slope and the y-intercept are exactly the same, it's exactly the same line, so there's going to be infinitely many solutions, okay? Because when two lines are graphed on top of each other, they intersect each other at infinitely many points. Now, just to give you an idea of what this line is going to look like, I start out at my y-intercept, which is 0, 2. Okay, so that's right here. And my slope is negative 1 over 2. So from there, I'm going to go down 1 and over 2. Okay? So from there, I go down 1 over 2, down 1 and over 2. And then I continue this pattern until I run off the grid. The reason why I do that is it's much easier to graph a straight line when you have that. Now you go up 1 over 2, boom, boom, boom. Okay, so again, it's exactly the same line, but please don't forget to graph the line. We need to see it. All right. Okay, now let's look at number 6. Now, again, one of these is in slope-intercept form and one of them is not. So this first one is in slope-intercept form. Okay, so I've got y is equal to 1x plus 5. So my y-intercept is the 0.05. So it's 1, 2, 3, 4, 5. Okay. And my slope is 1, which is 1 over 1. So from there I go up 1 over 1, up and over, up and over, up and over, and I keep going. And I'm going to extend it down and over. Remember, I'm doing the exact opposite when I'm going to the left. Down and over. And if I'm doing it correctly, it looks like a straight line, which is perfect. So, and sometimes this takes a little bit of time, but you need to make sure you're comfortable graphing lines. If you're not comfortable graphing lines, please come and see me and we can do some more practice. Okay, so the next one is x minus y equals 2. So I have 1x minus, and I'm going to put a 1 in front of that y, equals 2. So I have to put it in slope-intercept form, so I have to bring this x term over here. So this x term is positive. This negative belongs to the y. So be careful with that. So I'm going to subtract 1 times x from each side. Okay? And then I get negative 1 times y is equal to negative 1 times x plus 2. I'm not done yet because I can't have this negative 1 in front of the y. So I'm going to divide everything by that number. Now remember, don't just divide this number, you have to divide everything. So my solution is, I'm sorry, I got y is equal to 1x minus 2. Now, if you notice here, my y-intercept is 0, negative 2. And my slope is 1 over 1, right? If you notice, these guys are exactly the same. They have exactly the same slope. So they are parallel, which means they are not going to intersect. But let's go ahead and graph them anyways because we need to show that. So my y-intercept is negative 2. So that's 0, and I go down 2. And from there, I go up 1 over 1. And I continue that pattern on for as far as I can. Because when I'm practicing, I want to be as thorough as possible. And then from there, I can go down 1 over 1. You could also use a ruler to help you keep your lines straight. Okay. So as you can see, it looks like these guys are exactly the same distance apart and that they're never going to intersect. So in there, you don't say parallel, you say no solution. Okay? So when there's infinitely many solutions, you can write the infinity sign. If there's no solution, please write no solution. Don't say empty set, don't say anything, just say no solution. Okay? Now I want to show you one more. Here I've got a equation of a line where y is equal to negative 7. Now remember guys, when you have y is equal to negative 7, that's a horizontal line. That means that for every x value, y is going to be negative 7. So I would draw this like this. It goes right here. All right. And then I have 1x plus 3y equals negative 15. All right. So I've put it in slope-intercept form. First step is moving the x term. Remember, I cannot combine the 1x and the 15. This is a 15 and this is a 1x. They are unlike terms. They have to have the same variable. So I get 3y is equal to negative 1x minus 15. And then my last step is to divide by the number in front of y. Okay? Now, I get y is equal to negative 1/3 x minus 5. All right? So my y-intercept is 0, negative 5. Sorry about my hand. And my slope is negative 1 over 3. So from 0, negative 5, I go 1, 2, 3, 4, 5. And I go down 1 over 3. So I go down 1 over 1, 2, 3. Down 1 over 1, 2, 3. Remember to go through the whole process of the slope in order to do that. Notice that I hit this line when I went down 1, but I had to still go over 3. Okay? It should look like a straight line when you're done. So again, I can go up 1 and to the left 3. Up 1, 1, 2, 3. This is why I go both ways to make sure I'm writing this line out correctly. Up 1, 1, 2, 3. Oops. 3. Up 1, 1, 2, 3. Okay, so there we go. And here's my intersection point. So to get to this point right here, I go over 1, 2, 3, 4, 5, 6. So my x value is a positive 6 because I went this way. And then I go down 1, 2, 3, 4, 5, 6, 7. So that's negative 7. All right. Now this one right over here, I'd like you guys to try to get this one, try to do this on your own. But first things first, remember this x equals negative 2. Since this is a horizontal line right here, this one is a vertical line. Okay, so x equals -2. So that means every x value in this line is -2. So it's a vertical line that hits it right here. Okay, now take a minute and put this in slope-intercept form. Pause the video if you can and see if you can go ahead and graph it. Okay, hopefully you guys try to do this on your own. So I'm going to put this in slope-intercept form. First thing I do is I move my x value over to the other side. Can't combine these two because they're not like terms. So I have -2y is equal to -3x minus 18. And my last step is to divide by that number in front of y. And I divide everything by it. -2, -2, -2. So I get y is equal to, now be careful here, you have a -3 divided by -2, that's a positive 3 halves now. And -18 divided by -2 is a positive 9. So my y-intercept is 0, 9, and my slope is 3 over 2. So normally we go up 3 and over 2. But what do you see here? If I start here, I can't go up 3 and over 2, right? So I'm going to go down 3 and to the left 2. And what's nice is I hit the line right away. 1, 2, 3 over 2, right? 1, 2, 3 over 2, right? So there's my line. And my point of intersection is, if you notice, the x value is -2, right? And then I go up 1, 2, 3, 4, 5, 6. So -2, 6. So these are just some of the examples that we went through in class, just so you guys can prepare, and if you miss class, hopefully this is helpful. I will have this posted on Edmodo as well. Okay, have a great day. I'll see you guys next.